Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. Today we are going to look at average velocity versus average acceleration. Average velocity versus average acceleration. We already know the definition of what a velocity is, right? We said that velocity is equals to what? Displacement over what? Time taken. Is that okay? And you also know that acceleration is equals to velocity over time. Is that okay? So now these are the definitions of velocity and what? Acceleration. But now we want to look at the average velocity. So when we say that average velocity, what we are just saying is that the average velocity is the total distance covered with respect to what? Time. So let's assume that, so we say that the average velocity will be equals to total distance covered over what? Time. So here we can say that over total time taken. Is that okay? Over the total time what? Taken. So what you are saying is that let's assume that I'm traveling, okay? So I stand at point A. Then I move to point B. Then I also move again to point C. I can even move to point D, okay? Now, if I look at this one, from here to here, I will cover a distance. So let's say that is X kilometers. From here to this place, where I'll cover a distance, let's say Y kilometers. So let's name from A to C. From A to C, let me do it well. A to C, let's name it Z kilometers. Is that okay? So now, the total distance here means if I want from A to C, that's going to be X kilometers plus Y what? Kilometers. So that's the total distance, or I can represent it by Z what? Kilometers. Is that okay? Then the total time taken is that from A to B, as I'm moving with a distance, I'll also move with time. So let's name it T1, here T2. So the total time taken will be what? T1 plus what? T2. Is that okay? Good. Now, let's also look at average acceleration. So, average so for the average acceleration is a change in velocity with respect to the time taken. So you should know the difference. A change in velocity. So we are saying that average acceleration is what? Change in velocity with what? Time taken. By the time taken, is that okay? So this becomes the average acceleration. So the difference here is that here we are looking at the change. So let's assume that the car is moving with a velocity of, or the initial velocity of a car. Let's say this, we have, let me stand here again, point A, point B, point C. Now, as the beginning of the car, that is what we call the initial velocity. As the car starts moving, that is what our initial velocity. let's say at B, that becomes our final velocity, V. Okay. So the initial velocity and the V, you want to look at the change in this velocity with respect to what? Time. So here you can say that the average acceleration will be change in what? Velocity over what? Time, which is the same as U V minus what? U over time. So I have to use small t because so that is for the average velocity. Sorry, acceleration. In fact, is we can also have average retardation or deceleration. When we say something is decelerating, it means that that particular object is slowing down. It's not moving in opposite direction. So when the car is retarding, it's slowing down instead, not moving in opposite direction. So let's say the car is moving in a speed of 20 kilometers per hour. Then the car started decelerate or retard in a, let's say, 10 kilometers per hour. It means that the car is slowing down gradually, not stopping or moving in opposite direction. So you should know the difference between deceleration and velocity, where we have like negative velocity. For negative velocity, it means that the car is moving in opposite direction. So let's say there one car is moving this way and the other car will be moving this way. That is velocity that is negative, right? So that one, the velocity is moving in opposite direction. So when you work for a velocity and you get negative and you are asked to interpret, then if once it's negative, that means that velocity or that object is moving in opposite direction. But when you work for acceleration and you get negative, it means it is retarding. So the interpretation there is that that object is slowing down. But when the velocity the velocity is positive, it means that the object is moving in the same direction. Is that okay? And when its acceleration is positive, it means that the object is what? Accelerating or is moving faster. Now, so these are the formulas that we are going to use. Here will be total distance covered over total time taken for the average velocity and the average acceleration, the change in velocity over time taken. So the change is what we have here. Okay. Now so let's look at some examples. Okay, now let's look at this example. A, B, and C are 3 points in that order on a straight road with AB equals 40 kilometers and BC equals 90 kilometers. So we say that A, B, and C are 3 points in that order, okay, on a straight road. So let's say this is a road. Let me write solution here. So this is our road. So this is A, B, then C, okay? And they are saying that from A to B, we have 40 kilometers. So the distance from A to B is 40. So 40 kilometers. And B to C is 90 kilometers. This is not drawn to scale. B to C is 90 kilometers. A boy travels from A to B at 10 kilometers per hour. So from A to B, the velocity is 10 kilometers per hour, or the speed, whatever you want to put it. So we are saying that here is 10 kilometers per hour. Here we are represented by U. We are taking that as the initial velocity or the initial speed. Then B to C, and then from B to C at 15 kilometers per hour. 15 kilometers per hour. Okay. Okay. Now calculate the time taken to travel from A to C. The time taken to travel from A to B. Sorry, A to B. So let's see how we can do it. We know that speed, or let me go this way, velocity is equals to the displacement, okay, or the distance, depending on the one you are using. So if I'm using distance, which is s over what, the time, by one time, so my time will be equal to distance over the velocity. In this case, I'm using this velocity, so I'm using what, u. So my time will be, distance is what, a to b, the distance is 40, so 40 over 10. So my time here will be 4 seconds. Is that okay? 4 seconds, or sorry, 4 hours, because I'm working with kilometers per hour. Kilometers per hour, so it should be in hours. Then we also look for the II. The II is saying that the time taken to travel from B to C. B to C. So what will be the time taken? So the same formula. Time will be equal to the distance over what? The velocity. So my time will be, distance in this case here is 90 divided by 15. So my time will be, this will go here, 6 hours. Is that okay? So from A to B, we have 4 hours. B to C, we have 6 hours. Now the next one, the average speed of the boy for the journey from A to C. Look, that's the II. We said that average velocity, though the speed and the velocity have some different, but they are the same. The other one is a scalar, one is a vector. So average speed, we can also say average velocity, will be equal to the total distance covered. So the total distance, let's name it as S1 plus what? S2, because from A to B, the distance from A to B plus the distance from B to C, all divided by the time from A to B plus the time from what? B to C. The time from A to B, let's name it, and B to C, T2. So that will be T1 plus T2. So here you are going to get 40 plus what? 90 over 4 plus 10. 4 plus 6. Sorry. 40 plus 90, we have 130 over 10. So therefore, average speed will be equal to 13 kilometers per hour. Is that okay? So that is a solution to this question. Now let's look at another example. Now, second example. A car accelerates along a straight line road from rest to 70 kilometers per hour in 5 seconds. What is the magnitude of its average acceleration? So now here let's have these things down, the parameters. Now once the car is moving from rest, it means that the initial velocity is what? 0. Then final velocity will be 70 kilometers per hour, right? Time taken is 5 seconds. Okay. Now here we have two things to do here. Either you change the time taken here from the seconds to hours, or you change the 70 kilometers per hour to meter per seconds. Is that okay? So let's change this one to meters per seconds. So this will be, velocity will be 70 times. If I'm changing from kilometers to meters, I simply multiply here by 1,000. Then hours 2 is what? 3,600, because every 1 hour will give us 3,600 seconds. These 2 zeros will cancel these 2 zeros, leaving 700 over 36. Is that okay? So 36 can go into 7. Let me use calculator. That will be 125 over 6 meters per seconds. Is that okay? So when you do the conversion from the meters to the seconds, that's what you are going to get. Now, we want average acceleration. So average acceleration will be equals to change in velocity, which will be v minus u over time. So v is what? 125 over 6 minus u, which is what? 0, all divided by time, which is 5 seconds. So therefore our average acceleration will be equals to 125 over 6 all divided by 5. Okay, so that will give us, using a calculator, 50 over 12 meters per second what squared. Okay, you can try to change this one to decimals, no problem. Is that okay? So this will be the solution to this question. Thank you very much for watching. Please subscribe and share. Watch to the end to understand everything that we are doing here. Thank you very much.